All right, let me start reviewing from question number 29. Now, 29 through 32, what we're looking at in here is adding and subtracting fractions. I have more subtraction than addition just because there's one extra step in subtraction that I don't do in addition. The extra step is that I change it to a plus sign and I distribute the negative sign to the top of the second fraction. That's basically all I do. Change it to a plus sign and I distribute it to the top of the second fraction. If I had more than one term on the top of the second fraction, then distribute that negative sign to all the terms on the top of the second fraction. Okay, so now I have all as addition. Let's take a look at number 29. First, I gotta do is factor things out if possible. The first fraction I have 3p plus 4. Nothing I can factor. 3p over 4. See if there's anything that we can cancel. Now on the second fraction, I have the negative 3p on top. At the bottom, I have a 2. So I'm factoring the 2. P minus 1. Factor, cancel things out if possible. The second thing we got to do is think of your LCD, least common denominator. I focus on the factors that are numbers only. That's also why we factor numbers out. So I look at the factors that are numbers only, 4 and 2, and I think what's the smallest number that can be divided by 4 and can be also divided by 2. The smallest number in this case will have to be 4. So I'm looking at my factors that are just numbers. Then I look at my parentheses. So I must include that in my LCD. Okay, so now when I combine this, it's going to be combining to just one fraction. And I'm going to have a 4 and a p minus 1 at the bottom. That's my least common denominator. So then I look at my first fraction. And I said, how can I make my denominator look like my LCD? I already have the 4, so I don't have to worry about the first factor. But I do need a p minus 1. So multiply the top by p minus 1. I look at my second fraction. And I ask myself, how can I make the 2 look like a 4? Then I multiply by 2. I already have the p minus 1, so I don't have to worry about it. So from the first fraction, I get 3p squared minus 3p. From the second fraction, I get minus 6p. So to finish this, I have a 4 and p minus 1 at the bottom. On the top, combine your like terms starting from the highest exponent. So 3p to the second minus 9p. Now, how do we type this? Open parentheses. I'm going to go 3p to the second minus 9p, all of it inside parentheses because that's the top, divided by, at the bottom I have a big set of parentheses because I have two factors. Make sure you write each of them in its own parentheses. So I'm going to have a 4 and a p minus 1. That's how I will type it. All right, let's take a look at number 30. Factor things out if possible. Nothing can be factored out in this case. Then I think of my least common denominator. I must have an n plus 5 from the first fraction, and I must have an n plus 3 from the second fraction. All right, looking at the first fraction, I see the two parentheses I have on my LCD. And I said, well, I have the n plus 5, so I don't have to worry about it. But I do need, I'm asking myself, what do I need? I need an n plus 3. So let's multiply the top by n plus 3. Looking at the second fraction, I have the n plus 3. But let me multiply the top by n plus 5. You multiply it by whatever it is that you don't have. All right, so looking at the first fraction, I'm going to get 3m plus 9. From the second fraction, I'm going to have a negative 4m squared minus 20m. So my final answer, my LCD is there. So m plus 5, m plus 3. Now let me combine on the top all my like terms starting from the highest exponent. So I'm going to go negative 4m squared minus 17m plus 9. The way I will type it, let's make sure the top is inside parentheses, negative 4m to the second minus 17m plus 9, all of it inside parentheses, over the bottom. I have a big set of parentheses. Make sure each of your factor are in its own parentheses. So m plus 5, m plus 3. The order you write the factors at the bottom does not matter. So the two parentheses, it doesn't matter which one you write first. Just make sure you write both of them. So that's how you will type it. Let's take a look at question number 31. I see if I can factor anything. Looking at the first fraction, I can factor a 2. So I have a 2n plus 1. Once again, I factor numbers because when I'm thinking of LCD, I'm going to be comparing numbers only. Okay, so for my least common denominator, I see my numbers, 2 and 4. And I ask myself, which one's the smallest number that can be divided by 2 and 4? I have to say 4. That's my LCD. So I need, for my numbers, I ask myself once again, what's the smallest number that can be divided by 2? It can be also divided by 4. Then 4. For my parentheses, I must have an n plus 1. Okay. So my first fraction, I think of my 2. And I say, how can I make my 2 look like a 4? Have to multiply by 2. So let me multiply the top by 2. When it comes to the parentheses, n plus 1, I already have it. So I'm just going to multiply the top by 2. Looking at the second fraction, from the two parentheses I'm supposed to have, I already have a 4. But let me multiply the top by n plus 1. So from the first fraction, let me have 2n minus 10. From the second fraction, I have negative 5n squared minus 5n. So remember, at the bottom, I have my forward and my n plus 1. I have my least common denominator. On the top, let me combine my like terms starting from the highest exponent. Negative 5n squared minus 3n minus 10. The way I will type this, on the top, negative 5n to the second minus 3n minus 10. Notice that for exponents, I'm doing the little caret thing. Over. Now at the bottom, I have a big set of parentheses, but inside of it, I have a forward and I have an n plus 1. All right, let's take a look at number 32. Now the first fraction, nothing I can do, nothing I can factor. I'm just going to write 3 over 5v plus 6 plus. Now from the second fraction, I can cancel a v out of each. So let me write this as 4 over 5v squared. Notice how I simplify by canceling out a v. Now let's think of the LCD. My least common denominator. I must have a 5v plus 6, and I must have a 5v squared. From the two parentheses that I need to have, from the first fraction, I have the 5v plus 6. However, I need to multiply the top by 5v squared. The second fraction, I have the 5v squared, so let me multiply by 5v plus 6. So from the first fraction, I have 15v squared. From the second fraction, I have plus 20v plus 24. My like terms are already combined, starting from the large exponent. So that's my answer. That way I will type this inside parentheses 15v to the second plus 20v plus 24, close parentheses, over the bottom a big set of parentheses, 5v plus 6, and a 5v squared. Oh, 5v squared. Now tomorrow, from addition and subtraction, remember that section, adding or subtracting fractions, expect 2 of these on the test tomorrow. Now let's take a look at solving equations. First, I look at my denominators. So my focus is on my denominators. You see if I can factor things out. From the first one, I'm going to factor a p, so I get p minus 2. On the second one, I'm going to factor a p, so I get p minus 2. Here, I just have a p. Okay, so the first thing, when we're solving, so my mind is on the denominators only. I'm asking myself what values of p I cannot accept. Now, the values of p that I cannot accept are the values of p that are going to make my factors at the denominator equal to 0. So I look at my first factor. I ask myself, what value of p will make that 0? Well, 0. So I cannot accept it. I look at my second factor. What value of p will make that equal to 0? 2. So I cannot accept 2. Now here I already have a 0. For this one, I'm going to get a 2, which I already have. And here I have a 0, so I already have those. So I was looking at all my factors at the bottom to see which factors I could not accept. I also got to think of my LCD. I see they all have a p, so they must have a p. My LCD should also have a p minus 2, because I see some of them with a p minus 2. So let me multiply everything, every fraction, with a p and p minus 2. So let me multiply this with p and p minus 2. And multiply this with p and p minus 2. And the same thing here. Okay. So this p with this p cancel out. This p minus 2 with this p minus 2 cancel out. So I just get 4 equals. With the LCD, basically, I'm going to get rid of fractions. On my second fraction, the p with the p cancel out. The p minus 2 with the p minus 2 cancel out. So I just get 1. From the last fraction, the p's cancel out. Now let me distribute the 1. So I get plus p minus 2. So notice, I'm just working on this right now. Notice I don't have fractions. Let me simplify the right side. So the left side is 4. The right side is p minus 1. Now the minus 1, let me move it over as a plus 1. So I get that p is equal to 5. I double check the values of x that I could not accept. I make sure 5 is not there. It's not. So that means this is a good answer. The way you will type it, just type in 5. you don't have to worry about the p equals. Just type in 5. So the way I will type it is just 5. All right, let's take a look at number 34. Once again, my focus is only on the denominators. Let's factor them out. On the first one, I can factor an x, so I get x minus 4. On the second one, I can factor an x, so I get x minus 4. Here, I just have an x. So I'm thinking, what values of x I cannot accept? I guess I'm going to do it over here. What values of x I cannot accept? This first factor, thinking what value of x will make that 0? Well, if x equals 0. Second factor, what value of x will make that equal to 0? 4. From here, I get a 0, which I already have on my list. I get a 4, which I already have on my list. A 0, which I already have on my list. I was looking at each of my factors, asking what value of x make each of them equal to 0. Those are the values of x that I cannot accept. Then I think of my least common denominator. I see they all have an x. So my LCD should have an x. And should also have an x minus 4. So let me multiply each of these by x and x minus 4. Let me multiply this with x and x minus 4. Let me multiply this with x and x minus 4. Also, I see a minus in between my fractions. Let me change that to plus. And I'm going to distribute to this x and to this 2. So notice I have negative x minus 2 now. All right, let's get to work. On the first fraction, let me cancel the x. Let me cancel the x minus 4. So I get x minus 6. From the second fraction, let me cancel the x. Let me cancel the x minus 4. So I get negative x minus 2 equals. From my last fraction, let me cancel the x. So that's going to give me 3x minus 12. Let me simplify each side. The good thing that x minus x is 0, so that cancels out. So I get negative 8 equals 3x minus 12. To get the x by itself, the minus 12, let me move it over as a plus 12. So I have that 4 is equal to 3x. Divide each side by 3. So x is equal to 4 over 3. Now, how do we type it? Just 4 over 3. I know we're used to use parentheses and fractions. So if you use parentheses, make sure you put each of them inside parentheses. The homework will be accepted either way. All right, let's take a look at question number 35. My mind is only on the denominators. Also, I see there's a minus in between the fractions. Let me change that to plus and distribute the negative to the fraction that comes right after. So I'm looking at my denominator, the first one. Two numbers that multiplied equals 36, but when I add them equals negative 12. I'm thinking negative 6 and negative 6. My second fraction is just, my factor is just n minus 6. And for the last one, I'm going to get n minus 6 and minus 6. So let's begin with which values of n I cannot accept. Basically, the values of n that will make each of my factors equal to 0. So I cannot accept 6. My LCD. I notice that all my factors have an n minus 6, so I should have an n minus 6. But there are some of them that have 2 of them, so I'm just going to go with 2. My LCD is n minus 6 twice. So my first fraction, let me multiply everything with n minus 6 twice. The second fraction as well. And also on the last fraction. All right, so looking at my first fraction, this n minus 6 with this n minus 6 cancel out. N minus 6 with n minus 6 cancel out. So I just get 6. I'm going to write it over here. My second fraction, n minus 6 with n minus 6 cancel out. Now, negative 2 times n minus 6, that's going to give me negative 2n plus 12 equals, here at n minus 6 with another n minus 6 cancel out. So I get 4n plus 24. Let me simplify each side of my equal sign. So I have that negative 2n plus 18 is equal to 4n plus 24. The negative 2n, I'm going to move it as plus 2n. My plus 24, let me move it over as minus 24. So I have that negative 6 is equal to 6n. Let me divide by 6, n equals negative 1. I double check. Negative 1 is a good number. Okay. So negative 1 it is. If you guys are going to type it, just type in the number. Negative 1. All right, now looking at number 36. Factored if possible. Nothing I can factor. Now the values of v I cannot accept are 6. My LCD is v minus 6. So let me multiply this one with v minus 6. I'm going to multiply this with v minus 6. I'm going to multiply this with v minus 6. Also, the plus in between the fraction, the minus in between the fraction, I'll change it to plus, and I'll give the negative to the fraction that comes right after. From the first fraction, v minus 6 with v minus 6 cancel out. So 1 equals. Now that one is not a fraction, so I have to distribute it with v minus 6. So I get v minus 6 minus 5. So I have that 1 equals v minus 11. The minus 11, let me move it over, so it's plus 11. So I get that v equals 12. I make sure 12 is not on this list. So yeah, 12 is a good number. V equals 12. Now, from solving equations on the test tomorrow, expect 2 of them as well. Now, let's graph. Let's take a look at the graphs. First of all, looking at number 37, let me factor the top and the bottom if possible. So the top, I'm going to have x plus 3, x minus 3. Now from the bottom, let me factor 3 out. So that gives me x plus 2. From this information, I'm going to get either wholes. I'm looking for, if there's information about wholes. I'm looking for vertical asymptote. And I'm also looking for horizontal asymptote. Now, if I cancel any factors, that's going to give me a whole. What I mean with that is, let's say I had an x plus 5 on top and an x plus 5 at the bottom. Let's say I had that. I canceled those, so that's going to give me a whole. The way I'm going to figure out what the whole is, I think of what value of x will make that equal to 0 and find the corresponding y. Once again, that will happen if I had factors that cancel out. In my case, I don't have any factors that cancel out, so I don't have a whole. I'm going to write NA for not applicable. Now, vertical asymptote, I'm looking at the bottom. I'm looking at the denominator. And I'm thinking, what value of x will make the denominator, my factors of the denominator, equal to 0? From there, I get x equals negative 2. Now, for my horizontal asymptote, I look at the terms, the first term on each. If my highest exponent was at the bottom, so keep in mind I'm saying if the highest exponent was at the bottom, my horizontal asymptote is y equals 0. If the highest exponent was at the bottom. Right, there's a 1 up here. Now, if the exponents were the same level, the highest exponent was on the top and the bottom, then I just look at the numbers there, 1 over 3, And my horizontal asymptote will be y equals 1/3 if the exponents were the same. Now, because the highest exponent is at the top, in this case, I'm going to get a slanted asymptote, and I'm going to have to use long division. I don't have to finish the whole long division, but I have to do part of it. I'm going to do this as 3x plus 6. I'm going to divide it into x squared plus 0x minus 9. Remember, I cannot skip any exponents. I'm just looking at the first term divided by the first term. So I'm literally thinking x squared divided by 3x. I know that gives me x over 3. The way I'm going to write it here would be 1/3 x. Notice I took the x out of the fraction. Once again, I literally was looking at the first term on the top from the inside and the first term from the outside. All right. Now, 3x times 1/3 x. I know 3 times 1/3, basically 3 divided by 3 is 1, x squared. 6 divided by 3, because remember I have to multiply 6 times 1. I have to multiply with the top divided by the bottom. So 6 divided by 3 is 2x. I know I must draw the line and change the sign. So this is minus, this cancels out. So I have negative 2x minus 9. For my next term, I'm looking at these. And I'm literally going negative 2x divided by 3x. I know the x's cancel out, so I get negative 2/3. Once I have on the top a term that doesn't have an x, I don't have to finish my long division. My horizontal asymptote is going to be the line y equals 1/3 x minus 2/3. Okay, so I'm ready to graph. I don't have any holes, so that's good. My vertical asymptote is the line x equals negative 2. Now for my horizontal asymptote, I know it's a little slanted because I said it's going to be a slanted asymptote in this case. I remembered we used to draw lines y equals mx plus b. So I'm going to begin at negative 2/3. So on the y-axis, negative 2/3. In my slope, it says go up 1, 3 to the right. To do even better, I'm going to go up and 3 to the right again. So that's going to give me that. Okay, now when I look at my vertical asymptote, I know my graph should either be here. Remember, my asymptote is where the line is getting close to, or it's going to be here. There's going to be one of those two. Now, the way I'm going to find out, think of a value of x that is to the left of negative 2. So I'm going to think of negative 3. I'm going to find a value where x is negative 3. Now look at this equation. Looking at first parentheses. If x equals negative 3, my first parentheses, I have a 0. I have a negative 6 over 3 times negative 1. Notice I replaced negative 3 for x on each, and I just worked it out. So I have that this is 0 over negative 3. So my y value is 0. So I have a very good idea which one it is. So I know it's not this one. All right, now let's take a look at the right of the vertical asymptote. My graph, it's either something like this, oops, or something like this. One of those two. The way I'm going to find out, I'm going to choose a value of x that is to the right of the asymptote. Let's choose negative 1. Let me choose negative 1 for x. So from my parentheses, once again, I'm looking at this equation. I have 2 times negative 4 over 3 times 1. Remember, I was looking at x equals negative 1, so I worked each of my parentheses. So I have this as negative 8 over 3. So in this case, it's not this equation, this part. That's my graph. Now let's take a look at question number 38. Remember, I factored my function if possible. From the top, I can cancel an x. I can factor an x. So that gives me x minus 1. From the bottom, I can factor a negative 2x. So that's going to give me x minus 1. From here, I'm going to see if I can get any holes, any vertical asymptote, and horizontal asymptote. Now, the x minus 1 cancel out. So it's going to give me a hole. My hole is going to be, I'm going to look at value, x equals 1. Because I'm looking at what value of x makes that equal to 0. So that's a hole. Now, I notice that I also cancel this x. Oh no, never mind. Here, I don't cancel this. Let me start this again. When I factor the negative 2x, I got here at x plus 1. Okay, my bad. So on the top, I have x and x minus 1. Here, I factor the negative 2x, so I get x plus 1. So my holes, the only hole that I get is this one. That x cancel out. Thinking what value of x makes that equal to 0? 0. So the value of x. Now, for me to find a corresponding y, I'm gonna put 0 for the x on what I have left. So that gives me negative 1 over negative 2 times 1. So that gives me 1/2. Remember, I was just looking at x equals 0. Now my vertical asymptote, I'm looking at what I have left. I'm looking at what values of x will make my denominator equal to 0. And I get x equals negative 1. Now for my horizontal asymptote, I look at the very beginning. I look at my exponents. They're the same size. So my horizontal asymptote is going to be the line y equals negative 1/2. Basically, I just look at the numbers in front of it. Okay, so I'm ready to graph this. My vertical asymptote is the line x equals negative 1. My horizontal asymptote is the line y equals negative 1/2. I know to the left of my vertical asymptote, I either get a graph that looks like this or get a graph that looks like this. The way I'm going to find out, I'm going to choose a value of x to the left of the asymptote. So I'm going to choose negative 2. From my equation, find out the y value. So I have this as negative 3 on top. Then I have a negative 2 and a negative 1. So that gives me negative 3 over 2. All right, so that's this one. It's a little crooked, so let me go about there. Now on the second, to the right of my asymptote, it's either looking something like this or something like this. One of those two. I could choose a value of x to the right of my asymptote to find out which one it is. But in this case, actually, I'm going to use my hole. I see the whole, it's a 0, 1/2. So that tells me I'm supposed to have this one. That's it. All right, let's take a look at number 39. I'm going to factor if possible, so I'm just going to have the 1 on the top, nothing I can do. Here at the bottom, let me factor a -4. So that gives me x minus 1. So this way I'm going to find to see if I have any holes, my vertical asymptote if possible, my horizontal asymptote if possible. All right, so when I factored, I tried to cancel things out. Nothing cancels out, so I don't have a hole. My vertical asymptote, I'm thinking, what values of x will make the bottom equal to 0? So x equals 1. My horizontal asymptote, I look at the first term. Because the highest exponent of x is at the bottom, my horizontal asymptote is the line y equals 0. All right, so this is my vertical asymptote, x equals 1. My horizontal asymptote is y equals 0. Now to the left of my asymptote, remember I'm looking, it's either in this area or this area. So I'm going to choose a value of x to the left of my vertical asymptote. So I'm going to choose x equals 0. Because that's a value of x to the left of my asymptote. Now looking at my function, what I have 1 over -4 times -1. So I have 1 over 4. So that's about here. So that gives me my graph should be there. Now, to the right of my asymptote, I'm going to choose a value of x to the right of my asymptote. So I'm going to choose value of 2. To find my y value, I have 1 over, from my function, I have 1 over -4 times 1. So I have -1/4. So that tells me my graph is there. Lastly, let's take a look at number 40. Factor if possible. So I have x plus 4 on the top. At the bottom, let me factor the -4. That way I have the x by itself. I have x minus 3. I'm seeing if I have any holes if possible, my vertical asymptote and my horizontal asymptote. If I cancel anything, yeah, it gives me a hole, but I cannot cancel anything, so I don't have a hole. My vertical asymptote, I'm thinking, what makes the bottom equal to 0? X equals 3. My horizontal asymptote, I look at my original question. The x values are the same, so my horizontal asymptote is the line y equals -1/4. Just looking at the numbers in front of the x. So my vertical asymptote is the line x equals 3. My horizontal asymptote is the line y equals -1/4. Now to the left of my asymptote, choose a value of x to the left of it. I'm going to choose 0 just because it's easy to work with 0. So if x equals 0, look at my function. I plug in 0 for x. So I have 4 over -4 times 1. I mean, the bottom I have a -3. Remember, x equals 0. So I have 4 over -12. That's a -1/4. I mean, -1/3. So that gives me That. Now to the right of my asymptote, I'm going to think of a value of x. To the right of my asymptote, so I'm going to think, what about 4? X equals 4. So that gives me 8 over negative 4 times 1. 8 over negative 4, so that's negative 2. That's that. Now from graphs on tomorrow's test, expect 2 of these. I covered the first 4 questions on the test yesterday. I covered the last 6 questions of the test today. Tomorrow we have a test. I'll upload on Google Classroom the details about it. So there's 10 questions on the test tomorrow. You guys have 30 minutes. You guys will have to submit your work. You guys will have to take a picture of your work. I know how apps do the work, so I'm teaching you guys a different way. So it must be done my way. If it's done the way the apps do it, I know you cheated. Also, for those that do happen to have, those students that do happen to have the same wrong answers with the same mistakes, I know you guys cheated. And I remember, when there's cheating, I don't care who copy who, everybody involved gets a 0. All right, good luck tomorrow.